Welcome. This video introduces the PhotoChop project. We're going to talk about the data structures involved in it and then take a brief tour of the code, hopefully get you ready to work with the project. So in PhotoChop, we're going to be working with images, loading them from the drive, modifying them, and displaying the results. So the first thing we have to understand is how we're going to represent the data in an image. So usually images in a computer we think of in terms of pixels, individual squares that make up the larger image. And so we can take any image and break it down to a two-dimensional grid of pixels, of little squares, each with different colors. And those colors are determined by mixing three color channels, red, green, and blue. And most commonly, those color channels have a value between 0 and 255. Why? Well, because that's 256 different values or 8 bits worth of storage. So we have the values 0 through 255 for red, green, and blue for each pixel. If we have no red, lots of green, no blue, we get a green pixel. No red, no green, lots of blue makes a blue pixel. And if we start mixing them, we get different colors. Lots of red, lots of green, no blue makes a yellow pixel. If we have an even balance like 0, 0, 0, nothing of any color means black. 100, 100, 100 means a little of each color and they all blend together and make gray. If we have the max of every color, 255, 255, 255, that makes white. This is kind of the reverse of mixing paints. This is additive color mixing, where the more color we add, the brighter it gets. So to represent this idea in code, we're going to use a three-dimensional array. The first dimension will be which row a particular pixel is. The second dimension will be the column. And the third dimension will be for the three different colors. So we'll have this array called data here. It's got three dimensions. The size is determined by the image height, 128, the image width, 128, and this third dimension by the number of color channels, which is 3, the red, green, and the blue. The type that we're using for this array is a byte. So what's a byte? Well, it's type-deft, an unsigned char. So an unsigned char is the type that stores 0 through 255, but that's kind of wordy. So rather than saying unsigned char, we're just going to rename that as a byte. And we package together, we take this array and we put it inside a struct called image, mostly to make it easier to make copies. Right? We can't easily make copies of an array, but a struct we can copy just by doing an assignment statement. But really all this struct has is one member, this data array, with three dimensions. And so if I want to talk about, say, this right here, the blue part of this pixel, I'd say I want to access data, and then I want to go to row 2, column 0, so data sub 2, sub 0, and then to access the blue part of that, the blue channel of that pixel, I'd have 0, 1, 2, I'd want to access the color channel 2. Now rather than remember red means 0, green is 1, and blue is 2, we've got an enumeration for that. So color channel, we've got three choices, red, green, and blue. And so typically if I want to specify the green channel, I'll do that by saying something like, hey, go to pixel 0, 0 and get me the green part of it. So that's the structures we're dealing with. At this point we're going to go look at the project itself and check out how this is, where this all is in the code. So I've already downloaded the PhotoChop project, and if I pop it open, we've got a couple C++ files, a couple of those header files that you may remember from when we first talked about functions, and some image files, these BMP files, and then the PhotoChop project file. So I'm going to open that project file up and it'll ask me to configure things, and now we need to go look at the code. So main.cpp is where you'll do your work and where most of the code is. And down in main.cpp we have the main function. and it does some work to set up a GUI. And the work it does, we can run this to see the GUI it sets up. Basically, it's just going to make a window that displays the original image, and then that we can use to display the modified versions of the image that we make. So you don't have to worry too much about how this code does what it does. Just know that this chunk of code is making the GUI. Then we read in an image, so read in crab.bmp and store that as an image. So crab original is a variable of type image, and we get the information for it by calling read image. So where's read image come from? Read image and this other function, display image, are defined in image.io.lib.h. So this is a header file that has the declarations for two functions, read image and display image. And we can read this and read the comments to see what they're supposed to do. We don't have to worry about the code for these. If you want, you can go look in the image.io.cpp file and check out the source code for them. But the goal is for you to just use these as black boxes. Right? I know there's a read image function. It takes in the file name and gives me back the image. And that's all I need to know about it. So here in main.cpp, we call read image to get our image. And then to show the image in the GUI, I call display image and pass it my image that I want to display, a string with the title to give it, and then I have to pass it the layout that we're putting this in. And so you can see each time we do a display image, it looks like, hey, here's my image, here's a title, and here's the layout that we're putting it in. And that last part will always be just main layout. If we run this again, right, there's the strings. That's what's controlling what appears there as the little titles, is those strings we're passing in. The only file we haven't talked about yet is main.h. So main.h is where you can actually find the definition for byte, our constants, our enumeration, and the image struct. And those are in an .h file because we need to use them in multiple places. This image.io.lib needs to know about those definitions because it needs to know what an image is. And main.cpp needs to know about things like an image, so it needs to include that same file. So by putting those definitions in this .h file, we can kind of suck all these definitions into multiple places very easily. Now, you shouldn't have to touch anything in here. It's mostly just for, you can use that for reference. If you need to go double check what something is, go, what our height or width are, go check them in main.h. Or if you want to try loading your own image and it's a different size, you'd have to come change those constants. So back in main.cpp, well, we load the original image and we display it. And then the interesting stuff comes when we start trying to modify it. So to make the red crab, this one that's more red than the original, what we do is we take the original and pass it to this function redshift with the value 50. Basically how much red to add. And it's going to give us back a new image, which we'll call red crab. Right, red crab is of type image. And then we'll pass it to display image to see the results. So how does redshift do its job? Well, here's that function. It takes in the image that it's going to call source to work on. It takes it in as a reference parameter so that we don't bother making a copy of it. We're going to have it be a constant reference because I decided to have it not modify the original image. And it takes in how much red to add. It then makes a brand new image and initializes that with just a 0, which technically is only setting one pixel's very first color to be 0, but that has the side effect of making sure everything else is set to be 0 as well. So it basically starts as all black. And then we need to loop through for every single pixel for each row and for each column, and we need to set those values to be copies of the original. So for every row, for every column, take the current pixel, which would be like source, our source image, go to its data array, and get me pixel ij, and then get the red amount. So remember, this red enumeration is just going to get us the right index 0 out of the third dimension of our array. And so take the red from the source and add the shift amount, that 50 or whatever amount I passed in. And the result we're going to store into the new image's red channel. And then the blue and the green, we're just going to copy over directly. So get the source's data array, get the ij pixel, get the blue part, copy that into the blue part of pixel ij in the new image. Once we're done going through and copying all the colors for each pixel, we can return the brand new image. And that brand new image is what becomes back in main, is what becomes the red crab, and then we can show that one. Now you may have noticed, if I go back to red crab real quick here, or to Redshift, there's this function called a clamp. So I'm going to remove that just for a second and rebuild this project and run it. And notice that the red crab all of a sudden has some green. What's happened is we've added enough red so that places that were already really bright have gone past 255 for the red amount and wrapped all the way back to 0. And thus we've ended up with like some green areas. Right, that's the kind of thing we have to be careful of when we're programming, especially when we're working with data types like this byte that we're using that only goes from 0 to 255. It's very easy to wrap past the ends of that. So this clamp function is defined right here, and it's going to take in a value and just force it to be between 0 and 255. It's going to work with a double, so that it can take in a double, an int, or a byte, basically any numeric type. And then it'll return the value to us as a byte. So its return type is byte. So it'll take in a value, and if say we added 50 to a value that was already 240 and we got 290, clamp is just going to reduce that to 255 so that we don't wrap around the colors. There's a couple other examples. So this blur function makes the crab blurrier by blending each pixel with its neighbors. And then there's a couple examples, gradient and aqua, that don't even use the original image. So let's go look at make aqua real quick. Make aqua doesn't take any parameters because we don't care about the original image. We're just going to make a brand new image, start it off as all black, and then for every pixel, so each row, each column, take our new image, go to the data array, get the ith row and the jth column, set the green to be 128, set the blue to be 255, don't add any red, and once we're done with that, return the image. And if we set every pixel to be this much green and that much blue, we end up with that aqua color. Now your assignment is to use the guide and try implementing a couple functions. You can use the make aqua and gradient as examples for these ones. The red filter, you can take the ideas from there to do any of these effects. The blur filter, if you kind of reverse the process and change the numbers it's working with, you can turn that into a sharpen filter that makes edges pop and makes the image look a little bit sharper. Or you can do a motion blur or other effects. Because this is a C++ array, we can't change the size of the array, but what you can do is, if you want to do, say, a crop, you could just change the bottom and the sides to be pure black. If you want to crop it down to the center, you could just basically put black around the edges. If you want to just take part of the image and blow it up, you could do something like this and just take the upper left corner and copy each pixel into 3 other pixels so that you end up expanding one corner of the picture to take up the whole area. These pretty much go in order of complexity. These are pretty straightforward. The basic image filters are pretty straightforward. The complex ones and the size modifying start getting trickier. And the final category is ones that combine two different images, where you'd have to add code to read in a second image and try and say merge two images. Your task is to pick a couple different categories and to show me recipes for making at least one of these filters or effects from two different categories.